This is a skin, and consider the skin here is we call this infinite skin, because we don't have where it ends. So this skin could be just part of the aircraft fuselage, and we don't make this repair complex because this is it's not flush repair, so this area may not be will not be in the area where is critical for aerodynamic smoothness. If the area is critical for aerodynamic smoothness, and then we cannot have just a doubler patch repair like this. However, this is a concept. If you need to repair area where it is critical to the aerodynamic smoothness, then you just add up a filler. The doubler will be inside, and then you add up a filler here for you to have flush skin. So that's already different. Okay, what is critical here? Let me how to expand this. Okay, if you see here, let's open up another page. Okay, let's zoom this. Put it here. Okay, this is the doubler. Okay, which used to transfer the load which has been lost. Okay, so this doubler used to transfer the load okay, from the cutout. Follow me closely, okay. So we use this doubler to transfer the load. It used to be the load will flow through here on the skin, here on the skin, but now has lost because the skin has been cut off. Cut out the skin is standard, okay. Skin cut out is a standards for removing image. This is standard feature. If you don't cut, thing is it's not, something is not right. The repair will not be acceptable because you did not remove the defect. So that is a standard repair. Where you have damage, you have to cut out, and then you install the rivets. So the rivets will carry the load. So you look at here, shaded area. Okay, let's look at what are the shaded area. So the shaded area, you can see this shaded area here is shear load. So what is the load that you experience, or the load that you need to carry when you have cut out area? This area B is area where you carry shear, and then area A, tensile and shear. Okay, don't get confused, just leave it there. What you need to think is, when you cut this one out, you need, when you cut this out, this area no longer carry any load because the skin is not there. Remember, load is a simple uh, equation. Load, force, which is load, equal the material stress time area. So you have cut out the area. You have no longer, you do not have any more area. So the load cannot be carried through there. So now the load will be carried across the doubler. So it will jump through. The load will jump through here, go up here, go across and come down. So if you want to see, let me draw something for you. Okay, say this is skin. Okay, this is skin. So the skin can carry the load, no problem. Once you remove the area here, now it cannot carry anything. It's nothing there. So that's why you install doubler. So doubler, install rivets. I just show one rivets. Show rivets. We install rivets. So the load now will go to here, and they see the rivets, and they transfer across. See equilibrium. If you got 10 Newton here, from the skin here, hit this rivets, and then transfer up 10. And then the load will travel 10 Newton over the skin, and they hit these rivets, they transfer the 10 Newton down. Be careful, see the arrow, 10 Newton down, and reacted the 10 Newton. That's how the load transferred. And then that's why we use doubler to transfer the load, because you do not have any more skin that capable to carry the load. This is must be very clear to you, because if you understand this concept and this philosophy, then you have no problem. However, in the past, there are students who don't understand this, and I can see some put a doubler, there are no rivets. They are unable to understand why we need to calculate the number of rivets, because all those calculation to calculate the number of rivets based on how much load that we want to transfer, as well as the thickness of the doubler also will be important uh, on to transfer the load. So the thickness of the doubler also to ensure we are able to transfer loads across the cutout. You guys clear on this one?
Clear, sir.
Okay.
Yes.
So I will put a video on this and pass to you guys later. But this is very important. Similarly, on what we have done before on the doubler, on the angle repair, this is on the skin repair. The concept is the same. The only difference is because here is a skin. It's not as straightforward as we have an angle. Okay, we have an angle. We cut the angle into two. So we have another angle. And then we put a doubler to carry the loads. Okay, and we install rivets. We install rivets. We install rivets. So this is quite straightforward because the load is only in one direction. Tension or compression. Tension or compression. But here is a bit unique because it's cut out, it's skin, and it's only not having the tension and compression. It also have both shear. If you want to go detail why shear is part of the load of the skin, you may go and revisit your mechanics of material. So what happened here is when you have this cut, so the load carried supposed to be carried this way, say this tension. Now we have lost this. So for you to determine what has been lost, you also need to consider shear. So you need to consider this is tension, say longitudinal tension. You also need to consider this is shear here along this edge. Okay, this is shear here. This is V here. Okay, V circumferential. Why circumferential? Because you are talking about fuselage. Okay, this is a barrel. So we may be talking about here. So here is when you talk about diameter, you have pressure rise the aircraft, and the aircraft barrel is a barrel. You can consider it's a tube or barrel, whatever. They will expand. As they expand, we have tension along this diameter, and we can consider that as a radius. So that's why I said as radial or circumferential. That's why I said circumferential. Circumferential is something round. So we have shear along here, and we also do have tension due to the aircraft fuselage on the aircraft fuselage due to the operation of the control surfaces, and also due to the weights of the engine, of the wing, or the fuel, or the empennage. So for this, there's a unique loading. We have tension here, we have pressurized circumferential loading, and we also may have torsion. You also have shear. So we don't consider that a lot. We only consider longitudinal tension here, as well as consider the pressurized fuselage. So we also have load here, which is circumferential tension. Circumferential tension. We also have shear. Shear here is V, circumferential shear. So this is loading. So here we have this loading here. Say this is a P1, P2. Because we have two component loading, it should have resultant load, which is P1 plus P2 square root. So this is the P resultant. You have to calculate one here, one here, and one here. So but here and here will be the same. This side and this side will be the same. So only consider 1 and 2 for the resultant load. You guys clear now?
Yes, sir.
Okay. Now let's look at further.
Yes.
Okay, let me show you better picture. Okay. So we have shear, tension, 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 tension. So that is how the loading on the cutout. Sigma here is stress, tau here is stress. So from the load we have stress, we have tensile stress, and tensile stress on each of the each side of the cutout, and also we have along the cutout we have shear, and this we have to tackle, and all the doubler will need to carry the doubler that we design need to handle the load here, the load here, and the load here. Okay. So we may ask, how about this area? So more focus on here, because if you do carry tension, if you do have shear, all the load will be focusing around this area. Will be around this area. Remember, we have doubler. Doubler that we design is to transfer the load of here. So here, that's why some design or doubler you can see tapered. Okay. So mean they don't consider. So what they have a doubler that shape. If we go to aircraft, you can see some aircraft may have the pair doubler in this way. Why? Because the focus more on the here. That's where all the load transfer. This where all the load transfer. This where all the load transfer, and this where all the load transfer. Any questions so far?
Sir,
Yep.
macam mana kita nak tahu berapa banyak rivet nak kena guna untuk doubler tu?
Remember we have to calculate here the R. Okay. This is 1. This is shear. say this V, this is P, and then we have resultant load P square plus V square, so root, you got some number here R, so R, say R is 100 Newton. Okay, so the loads here, after you lost 100 Newton around this area. So when you lost 100 Newton, you need to transfer the 100 Newton. You lost here. So now this area no longer able to carry the 100 Newton. You need to transfer across using the doubler. You can just put a doubler, transfer through. If you bond a doubler, it's no problem, because the load will pass through. If you bonded doubler, okay, so the load will be transferred through the adhesive. However, we are not talking about bonded repair. We're talking about doubler mechanical faster repair. I mean, there's a rivets. So the rivet is used to transfer the load. So say you got 100, and say that you have rivets. The most suitable rivet that you can put in is having the strength of 10 Newton. Okay, that rivet having the strength only 10 Newton. That's what you have. So 100 divided by 10, you have 10. So you have to position 10 rivets here. You want to put in row, you want to put in pitch, you have to position 10 rivets here for you to be able to carry the 100 Newton over this area, over this area. And if you calculate R also 100 here, also on this area, on this area. How you get this number here? You go to the repair design guideline, which give you the strength of each rivets with diameter, the material type, and also on the skin that you want to install. They will give you the strength for each rivet diameter, which I have explained already before. Okay? Any questions?
Okay, sir. Thank you, sir.
So anyone do not understand, you can just message me. We can do online off the class. If you really have interest on this, because to me, if you really having the interest to work on the airline, so this is one of the most demanded job, and this is also the most sustainable job in the airlines or MRO doing maintenance on the aircraft, and also highly paid. And you also be able to work anywhere in the world, because I'm showing you the aircraft manual and I'm teaching you based on how you need to use the aircraft manual to design the repair. So you are already doing application here. It's not just a theory. Any questions?
So, kenapa kita kena biasa guna tapered? Kenapa tak guna petak tu?
Guna petak, yes, can. However, if you have constraint of weight, if you have constraint of I mean, this area is critical, you do not want to drill too many holes, you can opt for that. Because why? Because you see the load transfer only this area, this area, this area, and this area. This area basically you don't transfer any much load on this area. So all the rivet calculation, the thickness, everything only around this area, because this is a cut. So this is adjacent to the cut. This is a cut adjacent to the cut, this cut adjacent to the cut. So here is already basically that area. Okay,
Okay, sir.
because aircraft we do have in aircraft we design to be lightweight and we remove things not necessary. That's why you can see if you got like a beam, beam, and then you can see the beam, they make a hole. Okay, so that hole, the area doesn't carry load, so remove it. That's why you can see aircraft design this way. You can see a lot of holes. They got lightning, make it like cut. So we can do that. If the repair is big, yes. If repair is small, not necessary. However, if the area is critical for fatigue, we also may do this taper because we do not want too many holes. We do not want to carry, we do not want to drill too many holes on the structure because too many holes will cause will reduce the fatigue life of the structure. Questions? Okay, if not, what is the step you need to do? Okay, step 1, remember you have to calculate load loss, which is okay, material stress time loss area. Okay. Step 3, calculate double strength. Step 4, calculate reserve factor or margin of safety. Why? To ensure the doubler is capable to transfer loads. So if it's less than 1, then something wrong because the doubler is less strength and you're not able to cover the low slot that you have when you cut out the area. So that's why you calculate that. And then later you start to calculate the number of rivets. Okay. Based on the loss load. I, that is the load to be transferred. Okay, you follow me? So let's try to work out something. Say we have this cutout.
Yes.
Okay. And then remember this is skin. So it has thickness. It has thickness. Okay. So it's just part of skin. So here is the thickness. Thickness. Here is the thickness. Okay. And say this cutout here is 40. mm. And here is 30 mm. And thickness, say thickness of original 1.4. So what you need to do, remember we need to calculate the load loss. What has been lost, which to be transferred here. Okay, to be transferred here. Similar here. Okay. So this is our area of concern, because we need to determine how much to be transferred on here because we have lost this area. So you need to put a doubler. The doubler should transfer the load from this to this. How much? Because that you need to have the doubler to be able to transfer the load. So you have to calculate the load loss. Okay, the load loss will be in this area, or to be transferred here. Say here's P, and as long also you have shear force here. Okay, which is V. We put here is a VP. Say this is circumferential. Okay, I mean part of the aircraft. So this is somewhere here. So the P circumferential is around the circumferential. Here is V longitudinal, because if you look at the skin, imagine this is the cut. So here is longitudinal. Okay, here is circumferential because around the cylinder. So we put that convention. Here is circumferential, V is the longitudinal. And we also have load here. Okay. And we also have one here. And we also have shear here. So we can say here is a P longitudinal. And here is a V circumferential because along the cylinder. Okay, now we have to have two. For this area, the calculation will be P square plus V square square root. And for this area is P square plus VL square root. So this is the force here. Okay, this is a load loss. Load loss from this cutout which to be transferred through here. Clear? So how to calculate the PL? Okay, the material stress times the area. PL area will be 40 mm times 30 mm. You have to convert this to meter. I just put it straight there for convenience. But you need to convert to meter. Okay.
Yes, sir.
V is VC, yeah? Acting along this line. So similarly, this is shear time 40 times 30. Because this area is the same. Here, area here. which is here. Calculate to tension. Tension is area over, is perpendicular force over area. Shear, same area. Shear force parallel to the area. So you got PLVC. Okay, can you follow?
So far okay, sir.
Then similarly, you work out this area, okay, which is PL. Okay, P circumferential square plus V longitudinal square root. So we got this force here. So that's what we have here, loss. So similarly, what will be the area? P C will be the material axial stress. Here will be 30 time. Sorry, I'm really sorry. You should remind me. Okay, here is not 30. Here is thickness 1.4. Okay, 1.4. Thickness 1.4. Here 30 times thickness 1.4. So V circumferential, okay, V longitudinal shear stress times similar 30, because it's 30 here. Okay, 30 here time 1.4, and then that is the area. Any soalan? Any questions? Okay, let's pause for 5 minutes and have a look at it and ask question if you have any. If not, then I will proceed. Because you need to do this for your assignment.